All right. So we got one section left in chapter 3. And let's see if you guys are cool with this idea here. So if I have a line, does it matter which 2 points I pick on the line to find the slope? No. So to find slope, I can pick any 2 points. So I can pick 1 point, x1, y1, and then any other damn point on there, x, y, any other point you want, right? So in general, in mathematics, a little subscript means a specific given thing. So instead of writing, you see you guys will be cool with this. Instead of writing m equals y2 minus y1 over x2 minus x1, let me write it a little more generally. See how that says you have to have 2 specific points? Well, now we know better than that. We know if I get 1 point from somebody, I can have any other point that I really want. You guys cool with that? So that y and the x with no subscript on it just means any damn x and y that are on that line. Not any specific second point, but any of them.
With the subscript, what do you mean by subscript?
Yeah. The little number that's down here. Yeah, a little subscript. So whenever you see a little number down there in math or science, it normally means a specific, like very often in science you see T0, and that means the temperature, the original temperature. And then you see like TF, the final temperature. You know, the little subscript means a specific thing for some situation. So when I use this formula, it's when they give me 2 points. There's specific points they've given me. But here, this idea is more, if somebody gives me a point, I can pick any other point I want to, and it's got to be the same. If it's not the same, then it's not a straight line, is it? If it suddenly changes slope here, that's not a straight line, that's something else. And that, of course, is for later. That's when we start getting these guys. Is everybody kind of cool with that? So that's the big change here. It's not even a change. It's just this is more general. I don't like this down there. We don't like fractions in general. So can't I multiply it up? Is that cool? How do you kill a fraction in an equation? You multiply by the bottom. So I get y minus y1 equals m times x minus x1. That is another kind of formula for a line. So we have this formula, and we have this formula. Okay, so this formula comes directly from the idea of slope. And since the slope always has to be the same, and in fact, tell me this. In order to graph a line, what must I give you? What's the minimum amount of stuff that I have to give you?
2 points.
I can give you 2 points. I can give you less than that, though, as long as if I give you 1 point, I have to also give you the slope. So if I give you the y-intercept and the slope, you can graph the line. We've done that, right? Plot the y-intercept and then count by the slope, and you got the line. But I don't just have to give the y-intercept. Let me give you this. What if I say a line goes through, negative 2, 1, with slope equal to 1/4. Can you graph that line? Do it. I know. I'm just going.
You were like... Is there any rhyme or reason for why they use mx and b? Does it mean something?
The m is from a French word for slope. It's yeah. The b, I don't know. To be honest. Yeah. In statistics, we use ax plus b, which is fun. Every discipline has a slightly different way.
Yeah, I didn't have that because I'm a Brit based on that, but I guess not.
I gotta look it up though.
That's
I
alright.
keep forgetting. That's one thing. If you're a math major, you don't get as much history of math as you might think. So I've had anything I know about the history I've learned on my own. Kind of sucks. You don't get as much history of why things are the way they are. And that's actually important.
Because it comes easy to you and you don't need reasons why, like me.
I'll be quiet.
If you want a reason, I'll need
I always needed a reason. I never let my teachers off the hook. Right? Because it's the way it is. No! Why the hell is it that way? So, to plot this line, what do I have to do first?
Put down -2, 1.
Good, I got to start at a point on the line. The only point I know is that point. This kind of goes back to, I think it was your question from earlier. Maybe, or somebody. Do you need the y-intercept to correct? No. There's a point, -2, 1. And then the slope tells me to go up 1 over 4. So up 1, 1, 2, 3, 4. There's my line. Yes, sir.
When you just have the slope as just one number, do you put it over 1?
Yes.
Okay.
Yeah, so if you have like 5, it's 5 over 1.
Okay.
Yeah. Is everybody cool with that?
So if the question asks for a y-intercept, you could say it's 1.2 or something right there.
I'm about to go there. Hold on. Yes.
So it is -2 equals a quarter x plus 1?
Hold on. Here we go. Using our newly discovered equation. So if I can have an equation for the situation where I'm giving a y-intercept and the slope. You with me? So if I give you the y-intercept and the slope, you can draw the line and there's the equation. I should have the same thing if I give you any point x1, y1 and a slope. I can draw the graph. I should be able to have its own little equation, and I do, thank God. See, this equation, why is this equation not general enough? Because I need specifically the y-intercept. But to draw the graph, do I need the y-intercept? Do I? No, I don't need the y-intercept to draw the graph. I know it has one, but I don't need it. So I should have an equation that doesn't need the damn y-intercept either. That equation I got directly from something we've used many, many times. So that's just, this equation is really just that one reorganized. Is that cool? So it's nothing new, really. But now look at what the equation is. Now, x1, y1 is the point that you're given. And the point I was given was -2, 1. M, of course, is the same as always, the slope. So now plug in what you know. Y minus the y piece, 1. Equals m, x minus the x piece. Let me just let you guys absorb that for a minute. Bless you. So real quick, this one, who remembers what the name of that is? Slope intercept, because it's got a slope in the intercept. So that's the amazing, creative math brains. So what do you think they call this one? The one that's got the slope and a point. Now see, they decided to change it around. It sounded too much like the movie with, what's the name? So they call it point slope.
Point break.
Point break, yeah. Now that sounds more like point break. Yeah, you're right. Oh well. Yeah, I had a little bit of everything in that movie. But anyway, so point slope, because it has a point in the slope. Slope intercept, because it has an intercept in the slope. You guys kind of with me so far? So if I can draw the equation, I can have the intercept or a point. I should have an equation that has the intercept or a point. So here's my point, -2, 1. Do you guys see that? Because the equation is y minus the y piece, m, x minus the x piece. Now go with me for a second. Chris said earlier, the y-intercept with my ugly graph here looks to be just a little over 1, maybe like 1.2 or something. Right? Does that look about right? So if I can put this into mx plus b form, I should see the y-intercept sitting there, right? If I can solve this for y, I'll see the y-intercept. So let's try to solve this for y. This gets a little disgusting, so let me put this up here. Let's see, y minus 1. So again, just to make this point, there's my point, right? -2, 1. And m is 1/4. That's all I did was plug those things in. So how do I solve this for y? Well, first I can take this through, and very first I can do what in there? X plus 2. Now bring this in. Good. 1/4 of 2 is 2 over 4 is 1/2. And then what's the last thing I can do? To get y by itself?
Add 1.
Add 1.
Add 1.
Right? 1/4 x plus 3/2 or 1.5. Right? So this should be 1.5. So considering my ugly, my horrible, I need to get a giant ruler. At least it's between 1 and 2. All right, so let me tease out what's important from what I just did. Because whenever I do this, you guys, it's hard, and I don't blame you for this. It's hard for you to tease out, all right, what's him just talking, because Jeff talks a lot, and what's the shit that I'm actually going to have to do myself, right? So the important thing right now is to realize we have two equations of a line. We have this guy, and we have this one. So if I give you this situation, find the equation of the line that goes through -1, 5, and 2, 2, 2. Why not? Did it give you the y-intercept? No. Shit. So remember the problem we did earlier like this? I gave you the y-intercept, so it was cool. So now we realize in general I need two things. I can't use this equation here, really, can I? I'll actually show you you can, but let's just go with it. To use it directly, I've got a point. I don't have the y-intercept. So I've got to use this guy. That's the one that allows for any point. So to use it directly, this one requires the y-intercept. This one just requires any point. And how many points do I have? 2. I got it covered, man. I just got to pick one. Jeremy? Nothing. Okay. So I need two things. I need the slope, and I need a point. So somebody pick a point for me. 2, 2. I like it. It's got no negatives in it. Why not? How do I get the slope? Nothing new?
Down 1/5. It's like
No.
over
Careful.
2.
That's a point.
2 over 2.
That's a location. That's not a direction of motion, right? How do I get the slope from 2 points?
Just multiply the formula.
M equals.
Y
Okay, so don't forget that. That's your given 2 points. That's how we always find the slope between them. So I get what goes on top. Good. Y 2 minus y1, 2 minus 5. 2 minus -1. I like it. 2 minus 5 is -3. 2 plus 1. 3.
So it'll be -1.
So my slope is -1. Check. I got a point. Check. And now I just got to plug it into my equation. So if I'm given 2 points, I know that that describes a line. Any situation that describes a line, I should be able to get its equation from there. Right? If I can graph it, I should be able to get an equation for it, because those really are the same thing. The graph is the answers to the equation. So if I can get one, I should be able to get the other one. So I can certainly graph this if I wanted to. I don't need to, right? But I've got a point that I can throw in, and I've got the slope that we just calculated, right? Yeah. Okay. You guys are tested. So now we got y minus y1 equals mx minus x1. Y minus, what's the y part? 2 equals m times x minus the x part. 2. And then you just have to clean that up a little bit.
Why do we have to find the point if we found the slope and we have the 2 points and we already know where everything's at?
Because what does this equation require? It requires the slope. It requires the point. Right? So to fill in that equation, sort of like up here, Then we have a problem where if you have the y-intercept and the slope, you just have to throw them in there, right?
Mm-hmm.
What does this equation require? The slope and a point. So if I can get the slope and a point, I just throw them into the equation, just like we did earlier with this one. But this one I have to be given the y-intercept and the slope, and then I can just throw them in, right? So here, do I have the slope? Yes, we calculated it. Do I have a point? Yeah, I got two of them. You can use either one. So you guys chose 2, 2. Not a bad call. Stay away from negatives when you can. Why not? So now I just directly plug those in. Here's the slope. Slope is here. The point 2, 2. And now I just got to clean that up a little bit, right? Just like we did here. So I got y minus 2. What's the first thing I can do to clean that up a little bit? Check.
What is the y1 through 5?
If you picked this point, but somebody already told me to use this point. You can use either point you want to. And again, what was the whole point from where this came from? I don't care what point I pick. I can pick any point, right?
Right, but I thought the y1 was going off how we subtract it, like the 2 minus 5.
Not really. Either point could be y1, either point could be the second point, right? It doesn't matter. So you can use either point that you want to here.
So that 2 does not, I don't even look at the slope for that at all. I just look at the point, period.
Yeah, for this piece here, it just needs the x piece and the y piece. The slope, of course, needs both points, but we got that point, the slope already, so that would go here. So we got the slope here. We got the point that we picked here. And I'll do it the other way too. What would it look like if I used the other point? It'd be y minus the y piece, 5. Slope that we calculated, x minus the x piece, negative 1. So if I want to use the other point, see here's the other point, negative 1, 5. Pop. Or the point 2, 2. I'm going to come out with the same damn answer at the end. I better. Because the line doesn't give a shit which point you look at. It's the same line. How many points does the damn line have in it? Infinite number. I can use any of them. I only know 2 of them. I can use either one. So if we clean this up, what's the first thing I can do to clean this up?
Distribute.
Distribute. Good.
Add 2.
Add 2. Negative x plus 4. So clean this one up. First thing I should do is inside here. Make that a plus 1, right? And now I can bring the negative through. Add 5. Negative x plus 4. The same damn thing I got there. It's got to be. I mean, I got any point on that line, if you use it, it will tell you what line it's on. And they're all on the same damn line. So it doesn't matter which point you use. Yep.
So the question asks you then to find what the y-intercept is? Like actually say what it is?
Oh,
Write 0.
the question would be find the equation, but now it could be what's the y-intercept?
Of that equation.
So was I given the y-intercept? No. Did I find it?
Yes.
Yeah, what's the y-intercept?
0, 4.
0, 4, I love it. So did I graph anything? No. So there is a way to get the y-intercept without graphing. There's actually an easier way, but there's one way.
Thank you.
This is one of the, I never say this to make you feel like why even try, but I want you to realize this is one of the problems that people really don't like. And you can see why. Anytime there's more than one step to a problem, that adds to the complexity, no matter how easy each step is. Right? This step here is just, do you know the slope? No. How do you get it? All right, it's between 2 points. Do you know a point? Yeah, cool, got that. Now you just got to plug it in. Plug them in the right place and clean it up. Yeah.
Let's say find the equation for these points, and they do give you 0, 2, the y-intercept.
Then you would definitely just use this one. You could use this one. This works for everything, but this works.
It's a given.
Yeah, this works better for y-intercept because you just got to throw it in. All right, let's do one more example like this. And then I think that might be enough of that for right now. So let's see a different situation. Oh, I forgot. They have some of these in there. Oh yeah, they do. Yeah, yikes. All right, so the biggest mistake I see people make is they throw this in here and do something strange. These two have nothing to do with each other at all. My line is perpendicular to this dude and goes through this. So these don't necessarily have anything to do with each other, right? So what two things do I need to get the equation of a line? Slope, point, right? So, of course, the point's just given to me. Check. Right, so I got my point, then I'm going to throw the x piece and the y piece into my equation. So all I need now is what the hell m is. Now why can't I do it the y2 minus y1 way? I only have 1 point. So what thing in here actually relates to slopes? Yeah, perpendicular, right? If I knew this guy's slope, my slope, I know how perpendicular slopes are. So what is that guy's slope? His slope is 3/2. So if mine's perpendicular, what does mine have to be? Negative 2/3. That's the only thing this is for. Sometimes I'm a real dork, and I'll put here plus 11.897, because what does it matter? What does this 4 here matter? It doesn't matter where the damn thing. All I care about is this guy's slope. That's all I need. So I sometimes I put just ugly stuff here because I'm evil. You know that already, my math teacher. So now I've got this. What do? I just plug it in. So it's y. So see the stuff without subscripts? They have to be anything. You with me? So you can't put any specific value in them at the end here. They have to be y and x. But the y1 is the y piece. Yeah, so y minus the y piece equals m, negative 2/3, x minus the x piece.
One.
Good. Yeah.
So since we're finding the y-intercept for that, could you assume that x without the subscript is just 0, plug that in, so then it actually solves for the y?
You have to have the equation fully created first before you can use it to find things. So here I can only use information that I know to create the equation.
Okay.
If I had the equation, I could throw a 0 in for x and get it, yeah.
Okay.
I don't have the equation yet. So here I can only use the stuff that I know. Okay, and now you clean it up a little bit. So here this would be plus 3. What can I do over here? Yeah, bring that in. So what do you get? Negative 2/3 x plus 2/3. And what's the last step? Subtract the 3. How do you subtract these?
To make a
So you have to be ready for this,
LCD.
right? Fractions can come in anywhere.
So times
So you need
the
LCD?
1 by 3.
So multiply this guy by
3.
3. Right, this is 3 on the bottom. So it'll be 2/3
11/3.
minus
Oh, minus.
So
9/3.
Negative.
Sorry. I don't blame you.
The only part that I got out of this whole lecture was that right there. That last
Okay.
part. That's
All right.
subtraction.
Can you just go over the minus?
So again, let me back up for a second. I'll tell you this. Anytime I do something, if you're not sure about it, you ask me right then. So the worst thing to say to a teacher is, I don't understand from the beginning. Especially when there's a lot of parts. Especially when there's a lot of parts that I've already discussed before, and there was no real questions that came up. So, do we understand that this equation exists and I can use it?
Yes.
Okay, cool. If we understand this equation exists and that we can use it, we can then just say, what does that equation need in order to be used? It needs a slope, and it needs x and y piece of a point, right? And that's why this kind of problem can be broken up into two parts. Getting the two things it needs. Get the slope and get the point. The point was given to me. That was the easy part. The slope, I had to use the idea of perpendicular, right? So is everybody cool up to this point here? Now, the funny thing is, after this point, it's plug and chug. It's just put these things in the right place. That's the m that goes here, pop, x piece, there, y piece, there. And now it's just cleanup. And if your big problem is the fraction, on one level that's okay, right? Because fractions always kind of pop up out of nowhere and kind of give us a little heart attack. But if that's the big problem, that's almost okay. I can understand. We're not thinking fractions. And then all of a sudden a fraction is there. Holy shit, I wasn't thinking fractions. So let me back up here a second. Maybe it's a little bit clearer what's going on. So it sounds like, if you guys are being honest with me, everybody's actually cool to this step.
I'm not.
Tell me which step. No,
Well,
it's
I
okay.
just missed yesterday, so for me, this whole.
Oh, yeah.
I
Okay.
just need. So yeah, I'm not going to ask all the questions because it'll be the whole lesson.
That step is correct.
Okay, yeah.
Why don't we subtract 3 from 2/3 x?
Are they like terms? I could only subtract some x away from this, right? Yeah. So I have to subtract that from the number. Those are like terms.
When you're minusing fractions, I forget the rules, so you just go over that part.
Well, it's
So I know you have to minus 3 to get y
Yeah.
by itself.
subtract 3. It's currently 3 over 1, right?
Okay, yeah.
And of course, in order to subtract fractions, I need like terms. I have 2/3, but this is not something thirds.
So you need common denominator.
Common denominators. That would make it like terms.
Yeah.
So how do you make there be a 3 down there? Multiply by 3. And of course, whatever you do to the bottom. So then I get y equals negative 2/3 x. 2/3 minus 9/3. Negative 7/3. Now, if the main problem you're having is that's loaded with fractions, well, just let it go.
Okay, so you get the 9/3, then subtract that, because that
Yeah.
the denominator
2/3
common now.
minus 9/3, negative 7/3. Cool. Yeah.
Are you going to have these, the formulas written on the day of the test? Like, are you going to write them on the board, or are you going to have to remember those?
Where am I?
Like,
Sorry.
like,
Oh, these?
yeah, those.
Yes, you have to know them. Oh, come on. You have to know these formulas. You know MN's supposed to be. And if you don't, you better. This is the one that might be a little new or not as well known. But the funny thing about that one is if you know y2 minus y1 over x2 minus x1, it's one step away from that formula. It's the same formula. Just bring the x's up. And on the test, if you forgot something, you just have to come up and ask me. I'll harass you for a minute, but then normally you actually know it pretty well. You just maybe have one or two things, or you have it exactly. You're just not sure. And I just say, yeah, you got it.
So this formula is used only when we need for the point on the
Yeah, I can use this formula for any situation where I have any point in the slope. This one I can use when I know the y-intercept in the slope.
I'm still stuck on y plus 3 equals negative 2/3 x plus 2/3.
Okay?
That's where I'm stuck at. You did the reciprocal there, or what?
No. The only reciprocal we did was to get the slope.
Right.
So all I did here, just subtracted 3 from both sides. Right? Minus 3. Minus 3.
Right.
And in order to subtract 3 from the 2/3, I need to have like denominators.
But where did that 2/3 come from?
Distribute. Right? Negative 2/3 times negative 1 is positive 2/3.
Because the question's asking if it's perpendicular, so you flipped it.
Well, the question is asking for the equation of the line. And so we normally solve for y to put it into nice form. So the last step is always going to be this cleanup step.
Okay. I see it. I'm trying to.
I think the fractions are getting in everybody's way.
Well, at least in my way.
So again, so I'm there. After I plug stuff in, distribute. So negative 2/3 times x. Negative 2/3 times negative 1 plus 2/3. How do I get y by itself?
Minus 3.
Okay, I think I got it. That this I wasn't distributing the 2/3
Yeah.
into the 1.
And of course, here's where we had to multiply by 3 to make it negative 9/3. So 2/3 minus 9/3, negative 7/3.
I wasn't distributing the 2/3 into the 1.
Gotcha. Oh yeah. Bam.
Right.
Yeah.
You. So
Yeah, if this would have been parallel, I would have used the 3 halves.
Just looking for those key words when you get through that.
That's it. So if they give you 2 points, you can find the slope directly. If I say your line is parallel or perpendicular to this line, you find that slope and then do the right thing. Leave it alone and use it, or do the negative reciprocal if it's perpendicular like ours was. That was 3 halves, we had to make ours negative 2/3 because it was the perpendicular.
Well, it's not always negative, it's already a negative when you try to find a perpendicular slope. So the other,
You make it positive. Yeah, just change the sign.
that's what I was confusing myself with, the sign and distributing it over to the 1.
Well, negative 2/3
Yeah, and then
times negative 1
and
plus 2/3.
Right.
Cool. Okay. Yeah.
So, on the last formula, why isn't it, where's the addition sign after that? Why is it-
This
No. Different one.
here, 2/3 minus 9/3. 2 minus 9, negative 7.
But aren't we going by the x?
So again, if you have y equals mx plus b, is that what you're worried about? B can be negative.
So it doesn't have to be.
No. And if
okay,
I plug in here, like if m is 2 and b is negative 3, would we normally write it like this? No, we just make it minus 3. Cool. I like it. Yeah.
So is the equation m equals y minus y1 over x minus x1 the same as y minus?
Yeah. All we did was multiply the x's up.
So what's the difference between that one and m equals y2 minus y1 over x2? Minus
The only difference is this one supposes that we're given 2 points, whereas this one says we're given 1 point, and then any other point I use. Right? That's why in this equation, we substitute in for the point that we're given, and we leave x and y alone. They can be whatever the hell other point they want to be.
We don't solve for them either. In the end.
Yeah, we just solve for y, yeah. We got 2 variables, and we've decided we're going to solve for y in general. Yeah. Cool. Okay, maybe. I know there's a lot, but it is all kind of related. And if it's been a while, or if you've actually maybe never seen some of this stuff before, then obviously you got to let it sink in. Right? Summertime, you don't have the most time, but don't give yourself one class period to understand it, right? Give yourself, go home and do some homework, and then try to make sure you can understand it. All right, John says yes. Okay.
Actually, I'm watching the game.
John, it's all up to you, buddy. Priorities, right?
DVR.
Of course, the worst thing is when you DVR, but you go online to check email, and somewhere on the side.
Avoid everybody, man.
I know. No.
Somebody will text you.
You go to Hotmail or something, and you log out, and there it is. The top thing is, you know. Anyway, sorry. All right. Okay. So let me ask you this: if I give you an equation like this, can anybody tell me anything about that line specifically?
Yes. You could.
What's the slope?
We know the point.
Slope is 3. Yes, 3, and you can put it over 1 if you want to. What else do we know?
Points?
We know a point.
Your points are -2 and -4.
Careful.
Oh, no, 2
No.
and 0, 4.
Oh,
Yeah, what's the x piece of the point?
0,
2. What's the y piece of the point? 4. And why is it? Because, remember, the equation is... Yeah, this is what you're talking about. This specifically has a negative sign in the equation, so that number is the x piece. Right? If I would have made this a plus, I would have had to write it as x minus -2, then that would have been the x piece. The format of the formula has a minus sign, so if I want to actually see what the x piece is, minus, so it's 2. Minus 4, minus 1. So 4 is the y piece. Yeah.
Is that a rule in general? So let's say formulas are always a minus. If the formula is a minus and you're working with negative numbers, it's going to be in a parenthesis.
Yep.
With the negative sign.
Oh yeah. And we've seen that already, haven't we? I mean, when you do this, and my points are -1, -4, and 2, -5. Don't have to be careful. -5 minus negative. See, there's a minus in the equation and a minus on the thing I'm using. Right? We've seen that idea already. And the further you get in math, the more this kind of happens. We have general forms for things, and you have to be careful about what's in the general form so you don't mix it up. You don't say x is -2. It's not. The formula is x minus 2 is the x then. So then you can graph this if I really wanted you to, right? That would be the easy step, I'm hoping. Right? How do you graph this?
2, 1, 4.
Go to 2, 4.
You go to 2, 4.
And then go up 3 over 1.
Yeah, so 2, 4. Then we go up 3 over 1. Okay. Trust me, if I was a student in this class, I would require me to get graphic. So if you are at all like me, and my artistic ability shows it, get graphic or you'll drive me insane. Right? You probably don't want to do that. You don't want your math teacher to be insane. Somebody might say, well, you already are insane, huh? You're teaching math, man. You must be insane.
You seem to enjoy it. That's the really crazy part.
I know.
Yeah, anyone who's kind of naturally really good with numbers as well.
I know, but I have to say, when I do get something, I do get excited about it and I actually enjoy it. It doesn't happen very often.
Well,
but
and I'll tell you, the reason I enjoy math is because you guys understand that you're at the point where you're learning some of the skills required, and this is the reason why I'm glad we've changed the format so that we don't teach. We used to teach Math 90, and then we basically reteach all the same concepts in 103, and we just go a little deeper. But I'm always thinking that's going to make the students think that all of math is just, let's start over again and go even deeper. No, we progress. So now we got Math 90 goes up to a certain point in the book. Math 103 kind of does a review and then it goes further. Right? And then Math 170 or whatever you got to take after that goes even further. So I love math because I know what this leads to and what you're able to do with this. I couldn't do any of this really cool stuff if I didn't understand any of this stuff. Right? So some of this stuff is really cool. Some of it is basic skills that you need to be able to do the really cool stuff. Right? We all know that. I love to play basketball. I don't have the requisite height to really be able to do it at certain levels, but I had to understand, I have to have good balance, I have to have good passing skills and so forth. I have to do some boring stuff before I can really play a good game of basketball. I love tennis. Tennis is an even better example. Good God. Just all day, just hitting the damn ball, and then I hate that, and I never practice my serve. My serve sucks. But we know we need basic skills to be able to do the really cool shit, right? So I know where this leads. That's why I love it. Anyway.
I know. Can we get a sneak peek?
Just like, give us a little.
Well, when we get to factoring, I think that's where I can really give a good example of some cool shit. Related to...
Besides teaching it,
No.
what do you do with it?
Like your
Oh my God.
practical geometry, just tell them about the picture that you have, MCS, or you put the set, you put the number in, and it starts to make a pattern, right?
True, but that's nice aesthetics that leads to really good stuff, but it's not necessarily understood how that leads to useful stuff.
Yeah.
But it's cool.
But they found ways that it actually relates to like rainforest.
Crystal
and stuff like
formation.
that. Yeah.
Yeah.
What was that
like
thing I
very
told us
relevant.
about with the pine cones? That pattern
Yeah.
too?
Oh, dude. So
That's
Math 120
crazy.
Fibonacci sequence.
That's pretty cool.
Yeah. And if you
Never
count
let the pine cones the
trees,
same again.
don't get me started. Real quick before I keep going. This is what she's talking about.
That is cool.
The pattern in this sequence: 1 + 1 is 2, 1 + 2 is 3, 2 + 3 is 5. So if you look at a nice healthy pine cone, very often their seeds will show up in a number that's from this pattern. Now if you want to get really cool shit, you take a frequency of sound, and if it's really pleasing to our ear, it'll be maybe 2 frequencies played together. Will have will be if they're part of the sequence, together they'll make a really nice sound. If they're not part of the sequence, they make the sound that wakes us up in the morning. Right? That's really cool. So this is a very mathematical, just playing with numbers, and it leads to this kind of thing. The sounds we find pleasing. I mean, this is another direction of mathematics for sure. And I talk about this kind of stuff when I teach Math 120. Anyway. All right, let's get back to this here. Oh, come on.
But what is it? It's the pine cone. It will be like the little pieces on it. It's like one and just like 1, 2, like it goes down. Like that's how it.
If you count in a straight line as they go across, it'll be a number from that sequence.
Okay, yeah.
If you look at a tree and you look at the branches, if you count, so there's 1, 2, 1, 2, 3. As you count them up, if it's a healthy tree that hasn't been cut, then as you go up and you look across, as you count the number of offshoots, there'll be a number from that sequence.
That's crazy.
So for someone that needs all this math in life, what kind of job do they have? I'm curious to see what I'm understanding. It's like, well, I never use all.
All right, so
Like a mechanical engineer, civil engineer, you do it all the time.
the people that are doing like what I would love to be able to go back, if I could go back to grad school and finish out my PhD, because I only have 2 masters, I don't have any PhD. Yeah, they don't add up, come to find out. If I could go back, I would do the mathematics. Now here's a really cool thing, if you want to get into some cool shit. Normally, physics kind of either goes hand in hand or the math is ahead of the physics. So what I mean is, you've all heard of like the thing happening over in Europe, where they were worried that they would create black holes when they were slamming these things together. Because when you slam things together, it breaks up into its smaller parts, and you can do all kinds of things. So there's some physics called superstring theory, where the math is behind. The physics is there. They kind of know what should happen, but they don't have the math to plug stuff in and check it. So I would love to go back and be involved in developing that mathematics to then verify, and then you can start plugging in stuff. So this mathematics would be stuff like 11-dimensional mathematics, just to let you kind of know, right?
11 dimensions.
11 dimensions, yes. 11 true dimensions.
What dimension are we doing now?
Huh? we're doing 2. Right? And
The rest of it would say 1.
anyway, but you know, I've done. Anybody know Pandora? You ever heard of Pandora, the music thing online? All right. Ooh, that's a lot. Pandora uses up to what I've heard up to above like 500 dimensions. Because what it does is when you say you like a song or a band, it maps that. It has like 500 components of that song or band. And then it sees how far away those are from another song or band, and that's how it's able to tell, here, try this one. It's close to what you like. And then when you say I like it or I don't like it, that helps it figure out which direction that you like. Does that kind of make sense? That's a good example of 500 frickin' dimensional mathematics that we use all the time that we don't even realize that's part of it.
What's your other degree in?
I got physics and then math. Yeah. All right. So from 500 dimensions, let's go back to 2. Yes.
1.5.
Yeah. All right. So the last thing we'll do today, and trust me, guys. Oh, sorry.
Back before all that.
I'm sorry.
We were discussing graphic paper and
Yes.
do you accept NCS on the form? So we can just put NCS on there?
NCS.
Not just like-
Oh.
I'm just asking what your acceptance level is.
No, really. I mean, especially when I need the scale to be consistent. Now, there are situations where I've got like 50, 51, and then you can say right here there's a break.
But on the bottom right hand corner of that, I can't just put NTS in parentheses and then just put a variable representation of what I was doing. No?
Yeah, I definitely don't want to see graphs like this. I need scale to see what's going on. So I don't know if that NTS is an attempt to not have that scale. I have to see that scale because that's a big part of what we're doing. Using that scale correctly. So I have to see that. And that's why the nice thing with graph paper is it comes built-in scale. So you can make every tick mark 1, 2, 3, or you can make it 2, 4, 6. Right? So I can't take that. Now, I would never require you to be exactly perfect on your graphs, but I definitely need more than, because sometimes I'll get, that, and then there's a 3 there, and there's a 5 there, and -5. That's nowhere near good enough. Huh? That's a line. It's negative in the right place. I love it. I need a little more detail than that. They don't have to be perfect, because mine are definitely not perfect, so I'm never going to make you do more than I do. But they do have to have the ideas represented. The scale's got to be there. Slope might have to be there, whatever's involved in the problem. Is that cool? Understood? Okay. So this section 4.1. Let me ask you this.
What is this on? What's the topic?
Systems of equations.
Oh, yeah.
Okay. Can somebody tell me how many answers are there to this? I love it. There's an infinite number of answers here. Can anybody give me some of those answers? Good. So every answer's got to look like a point, right? 4 plus 4 works. 5, 3.
7, -1.
0, 8. Careful now.
No?
Negative 20, 28.
7, positive 1.
Oh, positive. Oh.
I love it. 10, -2. 900, -892. Right? So, I mean, that's just the idea that there's an infinite number. We already know that one main reason we graph lines is as a quick answer to this. What are all the answers? Bam. I can never list them all. Screw that. But my point is, there's no real just answer to this. There's many answers to this. And the reason there is no answer to this is because there's 2 things I don't know and only 1 piece of information. So if there are 2 things I don't know in an equation, somebody has to actually give me 2 pieces of information, which in this case would mean 1 more equation. So if I said x minus y equals 2, Can you actually pick out the exact answer now?
Yes.
All of these add up to be 8, like this first dude says. The second dude says they also have to subtract to be 2. Which one of those does that?
5 and 3.
5, 3. Let me just let that soak in. Is that cool? So if I'm given an equation with 2 variables in it, I have to be given 2 pieces of information to figure the whole thing out. So watch this. If I said I am twice as old as you are, which I hate the fact that it probably is true. If I'm twice as old as you are, can anybody tell me how old either one of us is? No. Now, if I also say, well, that you're half as old as I am,
No.
that's not really another piece of information, is it? That's the same damn thing I just said, just in reverse. So I have to tell you something else about the two of us, right? I have to say, ages add up to be something or other. You kind of with me? And that's kind of like the word problems we were doing before. You have to have 2 pieces of information to be able to do this. So this would be the answer. Now, what do you think that means if I graph these 2 lines?
It's an intercept.
One on top of the other one. If the line I make has all the answers to this equation, and the line I make there has all the answers to that equation,
The same one.
the point that answers both of them must be where the 2 lines meet. So to solve the system of equations graphically, I just graph each line and see where they meet. Is everybody kind of with me? So if a line is a collection of all the answers to that equation, throw another line on top that answers all that equation, the point where they meet will be the answer to both equations. I'll have one answer then. So I often think about this like solving a murder mystery, solving a crime. Mm-hmm. I collect information. There's a whole bunch of shit I don't know. Who did it, when they do it, why they do it, how long is it going to take me to solve this damn thing. So I collect as much information as I can to try to get all these variables known. You guys, I like to think of it like that. Okay, so let's try one fresh here. Actually, let's go ahead and, if we graph these 2, how would I graph these 2? What would I have to do to graph them easier?
Subtract the x.
Yeah, I'd have to get y by itself, right? So subtract x over. How do we get y by itself here? Subtract x, okay. Force it in there, just to get it in the mx plus b form. Is that cool? And then divide by -1. The negatives cancel there, the negatives cancel there. But 2 divided by -1. So here's my 2 equations, written in the best form for graphing. So you just graph each one. And here's my suggestion to you. Because I obviously cannot draw a straight line to save my life. Seriously, somebody had a gun to my head, I'd die. I couldn't draw a straight line to save my life. So what I do to help me, because you can imagine, we already know what the answer is going to be. They're going to meet at 5, 3. So if I plot 2 points and then draw a line, and then draw the other line, they are probably not going to meet in the right place, because I am not going to draw the damn thing straight. You guys kind of with me? So what I do then is I take many, many steps with my slope, so I know exactly where that damn thing is. Here's what I mean. How do I graph this first one?
Go to plus 8.
So go to +8. And then go down 1,
To the right.
over 1. Down 1, 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 over 1. Okay, that's go many, many, many steps. And then come in with the other guy. What do I know about him? What's the y-intercept? -2. And from there I'm going to go... I'm going to go where? Up 1, over. Up 1, over 1. Sweet! And what's that point there? 5, 3. The answer. So when I graph a line, I get all the answers for that equation. I graph another line, I get all the answers for that equation. What's the answer that works in both equations is where they meet. So section 4.1 is all about that. It makes sense. It comes right off the chapter we just came out of, because we just came out of learning how to freaking graph things. So this is kind of our first application, a real application of graphing, solving a system of equations.
It's a lot of sense, actually.
Thank God.
Yeah.
I don't hear that very often.
It looks really straightforward to me.
I like it. Of course, there's probably other people in here saying, that's nice for you. But I'm hoping this makes a little bit of sense. At least
You
in...
can always just do it twice and then wherever it needs, best solution.
That's the answer, yeah. Now the thing here is, will any two lines always meet? No. And that would be like, in real life, you know, I might get two conflicting pieces of information because maybe somebody lied to me in my investigation. So my information kind of doesn't go together. Mathematically, that would be the equivalent of two parallel lines. So if somebody gives me two parallel lines, there won't be any solution. If the answer is where they meet, and they're parallel, there's no solution. Is that cool? Yes, ma'am.
I don't understand how you graph numbers. I don't know how to do that, like up, down.
Oh, so that's the idea of using the slope. The slope is -1/1, right? So I start at the y-intercept of 8. And this tells me to go down 1/1. And my now that's all I need for the line. But I am not able to draw a straight line. So I just keep going. So these points kind of keep me going straight. And then I do the same thing here. So then I can see exactly where the points overlap. Right? If I just kind of draw two, I'm like, where the hell is that? I don't have a clue where the hell that is. You know?
And those lines are perpendicular because they're the
Careful.
reciprocals of.
Oh, these two are, yeah.
Yeah.
These two happen to be, yeah. Cool. They won't always be, but those two happen to be.
In that example, it is.
Yep.
Do you always, when you're, like, the negative x goes in front of 2, do you always do it like that with this?
Yeah, I strongly recommend you to do that.
Because it would normally be 2 minus x.
I love it. And 2 minus x is the same thing as -x plus 2.
And so how can you do it that way?
Because just to make it closer to mx plus b. Because the next thing I want to do with this is graphic. So you can certainly keep it as 2 minus x, you know, and then divide by -1. And make it -2 plus x, as long as you keep it straight. The problem is I have a lot of people tell me the slope is -2. Because they focus on the first number they see. But of course, if you're cool with that's 1 and that's the y-intercept, then that's beautiful, right? It doesn't matter what order it's in. The slope is always with the x. The y-intercept is always the number by itself.
You only do that when it's a negative, though?
No, I do it all the time. So, if I, and actually I already did that, I think. Like if I had this, what was the one I just did? I think it was this one. Yeah, I subtracted x and I shoved it in there. I can do that. Cool. And that's just to put it in the mx plus b form, just so there's no mistake made.
Is that line really perpendicular?
Yeah, again, my scale kind of sucks.
Okay.
You see how my scale here, there's a little smaller, these are a little bigger.
Okay.
So it doesn't quite look like a right angle.
Okay.
Yeah. So I'm fine with that. Okay. So really, that's all that's going to happen in these problems. They're going to give you two equations, and you just have to graph both. They're going to have to solve for y first, get the slope and the y-intercept, graph one and graph the other one, see where they meet. Some of them might end up being parallel, so there won't be any solution. What about this problem? So how do you make certain that it is? What do you have to do?
Plug in check or whatever, just plug
Yeah.
in and go.
In where? In both of them.
Exactly.
So if it works in one, it doesn't necessarily work in the other one. It's got to work in both. Because each one of these has an infinite number of answers. So 1, 2 could work in one of them, but maybe not the other one. In this case, it actually works in both. So that would be an answer to this system. So to be an answer, it's got to work in both equations. Cool. So you're going to see a bunch of them like this, and it's really just a plug and chug. Just make sure you plug and chug into both. And then you're going to see a bunch of them where they give you this, and you have to solve for y and graph it and get your own answer. Right? But then how do you check your answer? Plug it in both. Let's see if it works. Maybe. So, I'm actually cool if we can leave a little early, but I want to say this. Will the answer to a system of equations always be nice? Like 5, 3? No. So if the answer to a system of equations actually is supposed to be 1.89, negative 4.0229, I am never going to make a graph good enough to see this. I'll be able to say, oh, that's about 2 and negative 4. But I want to know exactly. So this graphical method is nice, and it lays the foundation for what the hell is going on. But the next 2 sections of this chapter deal with algebraic ways to solve this. Because graphical method breaks down quick. It's got to be like whole numbers, or maybe halfway between I could deal with. But the minute you get away from that, I can't do it graphically. No way. So we're going to learn 2 algebraic methods to solving any system of equations. That's the next things we'll be doing. And that's enough for today, right? Go Spurs. No, I just hate Miami.
I hate Miami too.